So this notation is something completely brand new. The graph of, make it a little bit bigger, f of x equals, and it's kind of like a double bracket. It's called the greatest integer function, aka also known as a step function. It's like when they clean the room or whatever they do in the room, I'm sure they come in and every time they see that this little thing is right here in the middle of the board for a reason, because then they move it over here and they come back in and they clean it and they put it back over here for some reason. So let's put it back over here. And then they finally, maybe the person who actually works in the room wants it right there. I don't know. So when people touch your stuff, don't touch your stuff. All right. Greatest integer, greatest integers. Integers 1, 2, 3, 4, 5. No fractions. Zeros an integer. Negative 1, 2, 3, 4, 5. No fractions, no decimals. Okay. It's everything except the decimals and stuff in between. So all the positive and negative whole numbers, but no decimals, no fractions, no square roots, none of that. So the greatest integer function, greatest integer, that's the misnomer. But when we talk about it, when we say this out loud, the greatest integer function denoted by the double bar x, technically, but it's the way they draw it, it actually looks like, I can never draw it well enough. Looks more like that. It's easier and quicker for me to just draw. And for some reason, I remember professors never drawing the actual symbol. They always just drew the two brackets. I always put this in the backwards. I can go over it. So, domain, you can plug in any number into here from negative infinity to infinity. So here's the deal. What you can plug in, you can plug in decimals, fractions, you can plug in square roots, you can plug in anything you want. But what comes out is an integer. That's the range. The range is only integers. The x-intercept, it's a half closed, half open interval from 0 to 1. And we'll see that in a second. And the y-intercept is exactly the ordered pair 0, 0. The answer is a constant between each pair of consecutive integers. And you'll see that when we graph it. And here's why it's called a step function. It jumps vertically 1 unit at each integer value. When you graph this step function, it looks like steps, like staircase. But when you do a step function, the best way to do it, the first time you graph anything, is to pick some numbers and plug them in. So here's how it's defined. The step of x is defined as the greatest integer. the greatest integer, the biggest integer that's less than or equal to x. I see that's where the, okay, you just broke my brain. It's the biggest integer that's less than, the greatest integer that's less than or equal to the x that you plugged in. So let's see what it looks like. So now we can generate this. Actually, I know what I'm going to do. Set up a window. Yeah, the -4 to 4 looks good. Y-axis, I'll do -5 to 5. Now, I didn't put anything into the function. Okay. And I wonder if I can do a zoom. If I do a zoom square, is it going to make that a little nicer? Yeah, that's fine. So I did a zoom square. It changed the x values, -7 to 7, but the y stayed the same. But now the graph is, it's more to scale. That's all. I'm still only going to go from negative. I'm going to use -3 to 3 because I don't want to plug in. You'll get the message when we just go that far. This is what cover up. So f of x is equal to the greatest integer function, the step of x, the greatest integer that's less than or equal to the x that we plug in. So here's what we're going to do. Here's x, here's your step of x, and basically the next thing would be your ordered pair x and y. Remember, f of x is just a way of saying this is what y equals. So this is going to be our x value that we plug in. This will be our y values that come out. And I'm going to go from -3, -2, -1, 1, 2, 3. First number I plug in is -3. So we're going to take the greatest integer that's less than or equal to -3. So let's verbalize that. On the number line, here's 0, here's -3. We want the biggest integer that is less than the integer that's less than or equal to a -3. So less than would be to the left of it, or it could equal the -3. Well, the only integer that would go next would be less than, would be -4. But if I plug in -3, isn't -3 equal to itself? Yeah. So the biggest number that's less than or equal to -3 is -3. So when I plug in -3, the answer is -3. -3 goes in, out here is -3. So there's a solid point right there, -3, -3. Now watch what happens when I plug in -2. -2, now I left some room because I got to do the in-between stuff. The biggest integer that is less than or equal to the -2. Well, when I did -3, I got -3. So the answer to this, the biggest integer that's less than or equal to -2, is going to be -2. So it's up here. And you might be, all right, I'll just connect the dots. That's not y equals mx plus b. It's something completely different. Something completely different. It's not a linear equation. I'm going to plug in one more. And this is not going to actually make my case until we do the in-betweens. -1. So the greatest integer that is less than, so smaller, or equal to a -1 would be -1. All right, that's good. Well, you keep getting what looks like a straight line going right through the origin. And the greatest integer less than or equal to 0 would be 0. And the greatest integer less than or equal to 1 would be 1. And the greatest integer less than or equal to 2 would be 2. And the greatest integer less than or equal to 3 would be 3. So of course you might think that it's going to be a straight line right through here. But what about the stuff in between? Again, it's not linear. So let's do the betweens. So in between -3 and -2, I'm going to plug in -2.5. -2.5. The greatest integer that's less than or equal to -2.5. So if I'm here, here's -2. If I'm here at -2.5, the biggest integer that's less than, to the left, or equal to -2.5. -2.5 is not an integer. So I have to go with the integer that's less than it. What's less than -2.5 is -3. So when I plug in -2.5, I get -3. So right here, I'm going to get -3. So it's side by side right here. If I plug in, get a little bit closer to the -2, -2.1. So the greatest integer that's less than or equal to -2.1. So 2.1 will be right here. Integer that's less than or equal to it, well, less than will be -3. 2.1 is not an integer, so I can go to -3. So -2.1, I get -3 again. So that means it's right here. And here's what you got to understand. I can get infinitely close to -2. 2.1, 2.01, 2.001, 0.00000000001, and the answer is still going to be -3. But when I plug in -2, it jumps up. So what's going to happen is everything between -3 and -2, the answer is going to be -3, except when I actually get to -2, there's got to be an open circle right there. Because when I actually plug in -2, it's not here, it's up here. And if it's a function, you can't have two solid points, one above the other. When I plug in -2, I can't have two answers. I can only have one answer for that x, and the answer is up here. But this means that open circle, I can get infinitely close, it just doesn't equal that -2, -3 points. And now let's just kind of go through every number in between here, -1.5. The biggest integer that's less than -1.5. -1.5 is not an integer, so less than would be a -2. -1.1, we get a -2. Everything in between -1 and -2, the answer is -2. Until we get to -1, when the answer is -1. And it jumps up again. And then you plug in the numbers in between. Negative 0.9. The biggest integer that's less than or equal to negative 0.9, well, 0.9 is not an integer, so less than 0.9 would be negative 1. You know, 0.25, negative, the biggest integer less than or equal is again negative 1. When you get to 0, the answer was 0, so it can't be here. Open circle, and it gets infinitely close to that negative 1. So you start to see the steps unfold, and that's not in the right place. Sorry, OCD takes over. That's a little better. And then in between 0 to 1, this is 1/2, 0.5. The biggest integer that's less than 0.5 is 0. So it's on the x-axis. The biggest integer less than 0.9, 0 again. When you get to 1, the answer is 1. Here, open circle, and then when we plugged in 1, we got 1, 1, 1. In between 1 and 2, everything that you plug in, the biggest integer that's less than or equal to those numbers is a 1. So it's going to go here, and then an open circle, because when you plug in 2, the answer is going to be up here at 2, 2. And then everything in between 2 and 3, 2.8, the biggest integer less than or equal to 2.8, less than is 2, not equal, that's not an integer. So it's going to go from here. And then when we got to 3, it jumped up to here. 3, 3. And then in between 3 and 4, it's all going to be 3s. And then between 4 and 5, it's all going to be 4s. And in between 5 and 6, it's all be 5s, so on and so on. And there's my steps. Doctor said I needed to walk more. I said I'm doing steps and plots. Okay? That's how you use step function. Here's how you use the calculator. So on the calculator, I'm not going to make this any bigger because then I would lose my spot right there. So it's under math. Okay, so I hit the math button, and then I go to the right where it says numbers. Okay, number 5 is integer. This is the greatest integer function. Okay, so I actually messed up, but you know what I didn't do? I'm supposed to graph this. I needed to actually hit my equation, y sub 1 first. Then I hit math, and then I slide over. Now you go down to number 5, enter the greatest integer of x, and then make sure you close the parentheses. Enter, and then I'm told tell me it's a graph. Now, the calculator, at least mine, is not going to show closed circle, open circle, closed circle, open circle. That's something you would need to do. Make sure you know what's which. Okay. So number 47 on the homework. Good. 47 on the homework. They wanted the step of x, and then we add 2. So this is going to help us do 1.5 when it comes around. So step of x, and then we add 2. So it's basically this function, but there's a plus 2. So this is 47. So right over here, there'd be a plus 2. So after you take the step of x, you would add 2. So we get negative 3 plus 2 So when we plug in -3, we get -1 instead. When we plug in -3, we got -1. If you plug in -2.5, you're going to add 2 afterwards. You're still going to get -3 because of the greatest integer that's less than or equal to -2.5. But then you're going to add 2 to that. So -3 plus 2 is going to give you -1 again. -2.1 plus 2, the greatest integer less than or equal to -2.1 is again -3, and then you have that plus 2. -3 plus 2 is again -1. So you're still getting, a horizontal segment. When we get to -2 plus 2, greatest integer is -2, and then we add 2, we're going to get 0. So it jumps up to here with an open circle. Sorry, closed circle. The -2 goes in, we get 0. So that means this is a solid line and then an open circle there. And then in between -2 to 1, the greatest integer is all -2s, but then when you add 2, the answer is now 0. Everything in between here, you're going to get a -2. But when you add 2 to that, all of the y's are zeros. And then in between -1 to 0, the old answer was -1. We kept getting -1 from here to here. We kept getting -1, but then you're going to add 2. -1 plus 2 is now +1. So this piece of the graph is going to jump up 2 units. So this is now solid there, and it's going here with an open circle. So that +2 is sliding all the steps 2 units higher. Everything went up 2 units. This one went up to here, 1, 2 units. This one went up 1, 2 units. This one up 1, 2. So this is going to be up here. Yeah, that's basically a shift, a vertical shift of 2 units. So shove, shift. Okay, choose your own SH word. When you spell shift, make sure you put the F in. Okay. Everything's going to get shoved up, shifted up 2 units. So when I change my equation, y equals, all I got to do is scroll over to the right of that and hit +2. Enter, and then hit graph.
I got some solid pushing down. Where's the graph?
Look at your y min and max. It's going from 100. Well, one and the other thing is, it is your minimum is 156,899.86, and it only goes up to 156,900. So it's this wide, but it's all the way up there at 156,000, and you're trying to do from and that's then the other thing is that's not -7 to 7. So you see? So what I did is I changed this and I put in -5 to 5. And the first thing I had up here, so my y scale is going to be 1. And over here, I put in originally like -4 to 4. And so with my graph, and then I hit zoom square so it looked like it was more in proportion to scale.
So it was a negative or shifted 1.
Everything was shipped down, it was a -2. And that's going to be all in 1.5. the horizontal shifts left and right, and the vertical shifts up and down, reflections left and right, reflections up and down. That's 47. Let's take a look at 49. So, perfect. Talk about the magic word of today. So this is the step of x minus 1. And then minus 2. So inside the greatest integer notation, we have an x minus 1. We're messing with the x's. And then instead of adding 2, we're going to subtract 2. Now, I'm not going to graph it yet. I'll use the same window. Because it says they want you to graph it by hand. So let's kind of do a little verbal walkthrough on this. Now, we already know what's going to happen for the most part in between the integers. We're getting steps. So we don't need to go from -3 to 3 anymore. Let's just figure out what's going on, between a couple of them, and then we can make the rest of the steps accordingly. So that's the idea. Is the first time you ever learn to graph something brand new, you got to make tables. What the heck is this thing going to look like? And then you start to explore what happens when you mess with certain things. What's it do to the graph? Then you're able to go, all right, I know what that -1 means. I know what that -2 is going to do to it. I don't need to plug in anything. I know exactly where everything's going to go, and I don't have to plug in any numbers. Maybe you want to just check a few, but then you're good. So I'm going to start x, the step of x minus 1, and then a -2, and then an order pair. I'm going to start with 0, and I'm just going to go from 0 to 2. 0, 1, and then 2. So this would be 0 minus 1. And then you take away 2. Now, so you can see a comparison. So you can see the comparison. This is the original. This would be the OG. Now, that's the second time in my life I've actually used that phrase. Original gangsta thing. Is that right? No. Now, I used to feel like I was hip. Now I just have this. And they hurt. This is the original. Okay, so let's see how all the other stuff is going to affect. What's going to happen? Okay. So you got to do what's inside first. So that would be 0 minus 1 would be the step of -1 minus 2. The greatest integer less than or equal to -1 is -1. And then you take away 2. So when you plug in 0, what comes out is -3. So when 0 goes in, we get -3 instead. When 0 goes in, we get -3. So right now, it kind of looks like it's just been moved down here. But all I see is -2. It wouldn't drop down to a -3 if that's a -2, so something else has happened. So let's plug in the 1, and then we'll talk about the in-betweens. When we plug in the 1, it's 1 minus 1 on the inside, and then you take away 2. So 1 minus 1 would be the step of 0. Then you take away 2. The greatest integer less than or equal to 0 is 0, and then you take away 2. And 0 minus 2, -2. So when you plug in 1, we get -2. So it's here. And then when we plug in 1, it's here at -2. So that point that used to be here at 1, 1, 1, that's been dropped down 3 units. So again, when we see -2, my assumption is only going to drop down 2. Something's fishy. Let's see if this one drops down 2. If it's going to drop down 2, then when you plug in 2, it used to be at 2. It should only drop down to 0, but what's happening so far, it's been dropping down 3. So let's see if it drops down 3. So 2 minus 1, and then -2. So inside, step of 1, -2. The greatest integer that's less than or equal to 1 is 1, -2, -1. So when 2 goes in, we get -1. So again, oops, 2 goes in, -1. So it's not dropping down 2, it looks like it's dropping down 3, but that can't be right. So let's see what's happening in between. So let's go straight to 0.5. If I use 0.5, that would be 0.5 minus 1, and then you take away 2. 0.5 minus 1 is -0.5. Minus 2. The greatest integer, so on a number line, here's 0, here's -0.5. The greatest integer that's less than or equal to -0.5. That's not an integer, so it's not equal. So less than is -1. The greatest integer that's less than or equal to -0.5. This is -1 minus 2. We get -3. So when we plug in -0.5, we get -3. 0.9. 0.9 minus 1 is -10 cents. Okay. Greatest integer that's less than or equal to -10 cents would be -1. -1 minus 2, we get -3. And then when you plug in 1, it jumped up to 2. So what's here? Open circle, and then jumped up here. So right now, we can probably make that next move. Because everything in between is going to be a segment like this, and then it's going to jump up. 1.5. 1.5 minus 1 is 0.5, a half. A half minus 2. Oh, sorry, I take that back. I didn't even do the work. Is a half. The greatest integer less than or equal to 1/2 is 0. 0 minus 2 is -2. So it is right here again. Open circle. (2.5). The greatest integer that's less than or equal to 2.5 would be 2. 2 minus 2
I didn't do it.
-1. See, this is what happens when I do stuff in my head. There's so many cobwebs up here, I should know better. 2.5 minus 1 is 1.5, 1.5. Greatest integer less than or equal to 1.5, 1. 1 take away 2, -1. So it looks like it's going to keep going like this. Plug in 3. 3 minus 1 is 2. Greatest integer less than or equal to 2. 2. 2 minus 2. These are going to be zeros. Plug in 4. 4 minus 1 is 3. Greatest integer less than or equal to 3 is 3. 3 minus 2 is 1. And of course, look.
We really behind on. You did it.
Well, you guys have had those things on. So anyway. The original. To the new one. It did drop down 2. But it also slid over 1. This segment right here. This segment is the one that dropped down 1, 2. This one right here dropped down 1, 2. Because if you think about what the rest of the graph on this side would be, this would be your open circle, and these would all be -4s for the steps. This one would be -5, open, open, and then it would be here. So this one has been shifted over 1 and dropped down 1. Oh, that's why. I made that too long. Here, okay. That's why. Okay. So this has been moved over 1 to the right. And then it's been moved down 2. This one went 1 to the right. And then it came down 2. The 1 is right here. If you mess with the x's, you're shifting the graph left and right, horizontal shift. Because it's the x-axis. If you mess with your x's, if somebody's messing with your x's, that's left and right. Now, you see how what do you see? -1, but it shifted to the right. What you're going to see in 1.5, so I'm hitting it right now to reinforce it. If you see minus, it's going to go to the right. It's basically what's in there is a +1. That negative that's inside the function is a built-in negative. So you need to do the opposite sign. If I saw x +1, then the shift would be a -1 to the left. You're going to do the opposite sign of whatever you saw. Because if somebody's messing with your X, they are a bad person. It's an opposite of who they are. I don't know. I just made that up yesterday. So the 1 moved everything 1 unit over, and then the -2, that is a K value. That shifts it up and down. Up and down, you keep the sign. -2 is going to shift them all down 2. If it was +2, like we showed you earlier, it moved it up 2. The only time you do the opposite is inside with the X's. That's the only time it would be an opposite. Graph here. Let's turn the equation on. Off. There we go. All right. That's 49. Piecewise function. And you're supposed to graph these by hand. We have a piecewise function is a function that has 2 separate pieces and the domain is explicit instead of implied. So this function is equal to the square root of 4 plus x. And that's only if you're plugging in x's that are less than 0. And then the function is equal to the square root of 4 minus x. And that's only if you're going to plug in x's that are greater than or equal to 0. So those are your 2 pieces. Less than 0 is to the left, greater than 0 is to the right. So when I do one like this, the first thing I do is right above, I call it the magic number. It's where the pieces are separated, the value that separates one piece, one side from the other. So what our domain is explicit by, to the left of 0 and to the right of 0. So 0 is what separates my 2 pieces. So over here on the left-hand side, for all the x's that are less than 0, remember that f of x is just one way to say the same thing as a y. This is y. So I can over here write, on this side of 0, I'm only supposed to use y equals the square root of 4 plus an x. And then over on this side, when you have x's that are greater than or equal to 0, I'm supposed to use y equals the square root of 4 minus an x. Left side, right side. one side at a time. So I'm gonna go ahead and do the left side first. Important when you do square roots. We like nice numbers. We don't want to plot square root of 2. Square root of 2 is a decimal, 1.414, but it goes on forever. You don't want to plot this. You like to plot 1. You like to plot 2. You like to plot 3. You like to plot 4, because those are nice numbers to find on a grid. When you're dealing with square roots, what you need is square root of 0, because that is equal to just 0. We like the square root of a 1 to happen, because the square root of 1 is just a 1. The next nice number would be the square root of 4, because that's just a 2. The square root of 9, because that's just a 3. The square root of 16 to happen, because that would just be a 4. What we want inside of the square root would be perfect squares, because those would be nice, easy answers to grab. Okay, that's your goal. So here's how you begin. The first number you plug in, the very first number, you always plug in the division. Wherever that function is broken, you start with this 0. So on this side, for the x's that are less than 0, I'm going to use y equals the square root of 4 plus x. So first thing I'm going to do is I'm going to let x equal 0. When I do that, I'm going to get an ordered pair. When you do this, you got to remember, is this going to be an open circle, open point, or a closed point? Only one of these can have an equals. Less than, greater than, or equal to. So when you do a piecewise function, it is a lot like you have the left-hand side and the right-hand side and a fence in between them. You have two neighbors that live next to each other. One of the two neighbors actually built the fence, paid for the fence, owns the fence. So therefore, they get to sit on the fence. The other neighbor had nothing to do with the fence. All they can do is get infinitely close to the fence, but they better not touch it. So whoever has the equals, they're going to get a solid point when you plot that point. Whoever doesn't have an equals, they're going to get an open point, an open circle. So if over here, when I plugged in 0, let's say I get 13, it would be an open circle when I plug in 0, if it was. Over here, when I plug in 0, let's say I got 2. Then for this side, we would start here with a solid point and graph that side with a solid starting there. Okay, one is solid, one is open, because you can't have two solid points, one above the other, wouldn't be a function. Okay, so we start with 0. When I plug it in, we get y equals the square root of 4 plus 0, which is y equals the square root of 4, which is just 2. So when I plug in 0 for x, we get a 2 for the y, and that is going to be an open point at 0, 2. Now, like any good neighbors, you have to stay in your own yard. This first piece only gets to use its domain, x's that are less than 0. So this first piece cannot go into this person's yard. They have to stay over here. Okay. When I plug in 0, I got a nice square root 4. Square root 4. The next nice number would be to get a square root of 1. Okay. What would give me inside that 4 plus x? What would give me a 1? What would x have to be to make a 1 inside here? -3. It would have to be 4 plus, and that would have to be a -3. That would give me a +1, and then I could use it. That would be the next best choice, is to plug in -3. So I'm going to let x equal -3. I get y equals the square root of 4 plus -3, which is square root of 4 minus 3, which is square root 1, which is 1. So when you plug in -3, we get +1. Right here. Now, this is a solid point. It's solid because that's part of the domain. You can use any x's that are less than 0. You just can't use 0. That's why it's open exactly at the 0. But for everything less than, they're all solids. So we made the 2 because we got a square root of 4. We made the 1 because we got a square root of 1. Now we like a square root of 0. So 4 plus what number would give me a 0? Say 4. So if I let x equal -4, I get y equals square root. 4 plus -4 will be 4 minus 4. So that's square root 0, and I get 0. And -4, we get 0. Right here. Now, so you see my pattern, 4, 1, 0. There's no perfect square that I can keep getting, which makes sense because if you went this way, let's say -8, 4 plus -8 is square root -4, which is not a real number. The domain stops. Yeah, they have to be less than 4, but the domain 4 plus x, that right there has to be greater than or equal to 0, the inside, because it's an even radical. Subtract 4, you can only plug in x's that are greater than or equal to -4 into this. And because it's also got to be less than 0, you can only plug in x's here that are greater than or equal to the -4, but less than the 0. It stays between here and here. In other words, like that. That's the left-hand side. That's all it is, just that one tiny little bit. And then on the right, the first number you plug in, you're going to let the x equal to 0, but because this has equals, that would be a solid point. Y is the square root of 4 minus 0, so y is your square root of 4, so y equals 2. So when you plug in 0, we get 2, which means that open, the next side, the right side, fills in that open spot with a, now makes it closed. It is a little bit like you take a plane, land in New York, you get out of the plane, you take a cab, okay, to, let's say, Broadway, you get out on the street, and exactly where you are on the street, a bus picks you up. So you got out of the cab onto the bus. Where the cab dropped you off, the bus picked you up to the next part of your journey. Where this function left you off, the next piece is going to pick up right there. It isn't always going to happen. Maybe the next piece over here, could be 2x minus 5. So then it would be a line that starts down here and goes up like that. It's whatever the pieces are. That's why we just do one piece at a time. 4 minus what would give me inside square root 1? 4 minus what number? 3. 4 minus 3, so when x is 3, we get square root 1. Square root 1 would be 1. Oh, look at that symmetry. And then 0. 4 minus what is 0? 4 minus 4, so at x equals 4, we get square root 0. Square root 0 is 0. And if you try to plug in 5, we get -1. We can't do that. On this side, it's just like this. And that's how you graph piecewise function, one piece at a time. You got to absolutely just focus. This over here, I'm only going to do this piece under this condition. And then when I'm done with that side, I'm going to focus on this side only under this condition. You got to stay in your own yard. That was 57. So now you get to choose 59, which is a 3-piece piecewise function, or 61, which is a 2-piece piecewise function. 59 is that one. And then 61 is this one. $59 or 61. Okay, yeah, 3 pieces. So now you've got a house on the left, a house in the middle, and a house on the right. It's equal to x plus 3 if x is less than or equal to 0. We get 3 if 0 is less than x and x is less than or equal to 2. And it's 2x minus 1 when all the x's are greater than the 2. Work. X's that are less than or equal to 0. So to the left and equal to 0, it's y equals x plus 3. And then in between 0 and 2, so this itty bitty little segment in between 0 and 2. So 0 is less than x, which is less than or equal to 2. It's y equals 3. Y is always a 3. And then on the right-hand side, the house on the right, for all the x's that are greater than 2, y equals 2x minus 1. So we're going to go from left to right, and we're going to start with this left-hand piece. The first number you plug in is that magic number that separates the left house and the middle house. You start with a 0. So when I let this x equal 0, that's going to be a solid circle, a solid point, because this house has the equals. So that's going to be a solid. And when I plug in 0, I get y equals 0 plus 3. So I just get y equals 3. And that's going to be a solid at 0, 3. The nice thing about this number 59, all three of these pieces are linear. That's a linear equation. X to the first plus a constant. That's a linear equation. That's a linear equation. They're all just straight lines. So all you need is one more point to graph the first piece. So I started there. I got to stay in my own yard. So I just need to pick another number that's in my yard so I can plot another point. I can only choose numbers that are less than or equal to 0. I've already plugged in 0. So I got to plug in something that's less than. So I'm just going to plug in, I'm going to use -4. And you can pick anything. I'm picking -4, so I have a little bit of, it's so small, so I have a little bit of room between. So y equals -4 plus 3. And that's a -1. So when we get -4, we get -1. -4, we get -1. So the first piece of this graph in its own yard only can go to the left of 0. So it's only this. But it does go forever, so there's an arrow that goes with it. So that's the left house. The house on the left, which is a really, really awful movie. And I don't recommend seeing it unless you're into really creepy crap. And then between 0 and 2, between 0 here and 2 right there, then this function takes over, which is kind of nice because this is a special case. When you have y by itself, it's a horizontal line. It's a horizontal line where y is always a 3. So the first number you would plug in is the 0, and it would be an open circle when you plug in 0. It would be open at x equals 0, but when you plug in 0, y is always a 3. So this one has a solid. The next one would start with an open circle. It stays solid because that's where the last one left. So it's like the cab dropping you off and the bus picks you up. They just happen to be one on top of the other. And then you only need one more point. So let's go all the way to the other side of the interval. It stops at 2. So let's plug in 2. When you plug in 2, the y is always 3 because it's a horizontal line. That's who has the equals. 2 has the equals for the middle house. So that's going to be a solid point right there. And that would be a horizontal line in between. So that's the middle house, and then the house on the right. For all the x's greater than 2, the first number you're going to plug in is 2. You always start with that cutoff number. Because there's no equals for the right-hand side for the right house on the right, when you plug in the 2, it's going to be an open point. y equals 2 times 2 minus 1. So y equals 4 minus 1, we get a 3. Imagine that. I really wish they would have not given us where it all connects, but they're just giving us connecting ones. So there's an open circle on top of the closed circle, so it stays closed, but that's where the next piece would pick up. And because it's linear, you just need another point to complete the graph. You have to pick something bigger than 2 because you got to stay in your own yard. So I'm just going to go ahead and pick 5.
Wouldn't matter what.
It doesn't matter, but if I pick 14, it's probably going to be too high. So I'm just going to pick 5. So y equals 2 times 5 minus 1. So that's 10 minus 1. So y equals 9. Yeah, and when I do a test, I always make sure that the whatever graph I ask you to graph, I always give you a grid to graph it on the test, and I always make sure that whatever I've given you the equation fits nicely with those numbers. So when 5 goes in, we get 9. And so the house on the right starts here at that 2, 3. It's 2, 3, and it goes this way. And only to the right, that's in your own yard. That was 59. Okay. Graph it with a graphing calculator, determine whether it's even, odd, or neither. So 63, f of x equals 5, so y. So here's an important thing. If I try to graph this thing, and I keep the window as I have it, from -7 something to +7 something, and my y is -5 to 5. So I don't change my window and I'm not paying attention to what's going on. That's when bad things happen. Like that. That's way up there. So we know that the graph y equals 5, f of x equals 5 is a horizontal line at 5. So if I really want to see this, I might want to change my y maximum to be a little bit bigger than the 5 so I can see what's going on above it. So I might go change that to a 7. That's all I would need to do. So I can actually see what's happening. Oh. Now, definition of odd and even, or neither. So basically, the answer is neither if odd doesn't work, even doesn't work. Camera. F of x is even if f of negative x is equal to the same as f of x is. In other words, f of -2 gives you the same answer as f of +2. The y values are the same to the left and right of the graph. Left and right, the y values are exactly the same. F of x is odd if, when you plug in negative x, f of negative x, that's going to equal the opposite of f of x. So in other words, if you plug in f of -5, that would be the opposite of what f of +5 is. The sign changes on both x and y. So that's a reflection across the y and the x-axis. So if you have 3, -2 on one function, okay, so with my if you have 3, -2, and then you have -3, +2, when I change the sign on the x's, the y's also change. It's the opposite of that one. So when I go to the other side for the x, the y is the opposite sign as well. If I plug in +4 and I get positive or -3, and then when I plug in -4, I still get -3. The left side and the right side, I get the same y value. So right here, when I plug in 1, I get 5. When I plug in -1, I get 5. When I plug in 1, 2, 3, 4. When I plug in 5, I get 5. When I plug in -5, I get 5. It's even. Even functions, they have symmetry across the y-axis. So left and right side are exactly the same. So 63 is even. 65. 3x -2. Okay, if it's even, then what you see over here should reflect over there. It looks like when I plug in 2, it looks like I'm getting a 3. So when I plug in -2, I should also get a 3. And I'm not even. So if this is 2, 3, and if it's odd, then over here, I should get -2, -3. If I change the sign on x, the y also changes. So -2, -3 is right here. Whoops. 1, 2, -2, -3 is right about here. And that's not true either. So since it's not even, it's not odd, this would be an even. Right? All good? Yeah. 73. Find the coordinates of the second point on the graph of F. So if it's even, what would the other coordinate be? And if it's odd, what would the other coordinate? So 73. A, we want even. B, we want odd. So if it's even, if I plug in this is a positive. So when I plug in the left side, I would plug in -3/2. If it's even, what would the y be? The y value be? If it's even, when I plug in the left-hand side versus the right-hand side, I get the exact same y value. So when I plug in 4, I got -3. When I plug in the other side, I still got the same y value. It's even. It has to be the same y value. Same y value. No, it's not going to be horizontal because it could be, parabolas. Over on this side, you have this -2, let's say -2, +1, I don't know. And over here, +2, +1, and over here, -2, you would have -2, +1. So when I change the x, but the y is the same. When I graph y equals cosine x, it looks like this. When I plug in negative pi over 4, I get square root 2 over 2. And when I plug in positive pi over 4, I get square root 2 over 2.
That's what you would have.
Trig.
All right.
Right. So this side, that side, the x's are just opposite signs, but the y remains the same for each. Reflection across the y-axis. So if it's odd when you change the x, the y is also opposite sign. If I have 3, -2, change the x, then I change the y, then it's odd. So if I change the x to -3 over 2, what's the y value if this is an odd function? It would be -4. You change both if it's odd. If it's even, again, what's making this happen is left side, right side, so the same distance from 0, because that's the only way to establish symmetry. The symmetry is what matters about the y-axis. For even, so that would have to be positive x, negative, positive 5 versus negative 5. So it has to be the same x value on each side. So now you get to pick 75 or 77. Oops, that happens. 75 or 77?
77.
75?
77.
77. So we're starting with x negative 1. If it's even, so that means we're going to change the x and use negative x instead. If it's even, the y value stays the same. The y value is exactly the same thing. So the y value was negative y, the y value would still be negative y. If it's odd, both signs would change. You go from one side to the other side, it would be positive x versus negative x, positive 3 versus negative. So you change the sign on the x. So if it's odd, that's x, this would be negative x. You change the sign on both of them. This would be positive. It moves on. Yeah, basically, yeah. 79. Determine whether the function is even, odd, or neither algebraic. Then graphically by using a graphing utility, and then numerically by using the table feature and comparing f of x and f of negative. I'm just going to show you how to do it algebraically. Okay. So we're given f of t.
Are you still going to want us to do it?
Yeah, because you should follow the directions. But I've already done the graphing part of it. Now, the number stuff, that's, I don't mind if you don't do the whole number thing, because you can try an infinite number of numbers. Not everybody's going to try the same numbers. But definitely you should graph it and see the symmetry if it exists. So f of t is equal to t squared plus 2t minus 3. And make sure you start getting used to, whenever you got to use t as a variable, make your t's a little hook to it, so you don't get them confused with pluses. Will save you a lot of misery. All right, so instead of x, if it's even, then f of negative t would be exactly the same as f of positive, or f of positive t. When you change the sign on that t value, you get the same y as you did before. If it's odd, when you change the sign on t, you'll get the opposite answer from your original, f of negative t, or negative f of t. So, for algebraically, we know that this is f of t. So what you have to do is plug negative t in. We know what f of t equals. What does f of negative t equal? So that means I'm replacing this t with a negative t, which means everywhere you see a t, you're now going to replace it with negative t. Every t becomes a negative t. So first thing you're doing is squaring. Whenever you square, especially negatives, and let's just get used to always good habits, parentheses, negative t, and then you're going to square it. Then plus 2 times. That t becomes times negative t. And then you have a minus 3. So f of negative t, a negative t times a negative t. A negative t to the second is positive t squared. Positive 2 times negative t is negative 2t. And that's a minus 3. That's what it equals. That's exactly what you get when you plug in negative t. So now we have to answer the question. The original was f of positive t, t squared, plus 2t minus 3. Are they exactly the same? No. Therefore, it's not even. Are they exactly opposites? So here's the deal. If they're opposites, all the signs would have to be changed. Only positives. So what they mean by opposite, if we would have had odd, this is what would have happened for odd to have happened. This whole thing, you'd have to have a negative in front. Which means if you distribute the negative, you would have a negative t squared. A negative times 2t would be a minus 2t, and a negative times a negative would now be a plus 3. That's what opposite would have ended up looking like. We did not get that. So it's not odd, it's not even, this is an even. But that's how you check it algebraically. You actually plug in, if it's x, you plug in negative x. If it's t, you plug in negative. And then you compare, did I get the exact same thing, or did I get the exact opposite thing? And if you didn't get either one of those, either. Okay, so now you get to choose. You want me to do 81, 83, or 85 for that same group? Avery? So 83, f of x is x times the square root of 1 minus x. Actually, this is where I'm working. X is equal to x times the square root of 1 minus x squared. I'm gonna have to figure out what does f of negative x mean. So I'll either get exactly the same or the opposite of x square root 1 minus x squared. The exact opposite. Okay? And if it's not one of those, it's neither. So I'm going to replace these x's with a negative x instead. So that gives me this x is now a negative x. Square root 1 minus this x squared, so parentheses, is now a negative x, and you're going to square it. So you see how in parentheses is so important, especially in here, 1 minus, and then I plug in the negative x squared. If you don't use the parentheses, you may think that's 1 minus a negative, so 1 plus. No. Order of operations, you have to square that negative x before you subtract. And that's what bites everybody in the behind when you're doing high-level mathematics, is you just have bad habits. And you don't take care of substitutions, you try to do things in your head. I wish I could go back in time and tell myself that. So f of negative x is equal to, well, that's negative x square root 1 minus negative x squared, so negative x times itself is positive 1 minus x squared, which is basically negative times x square root 1 minus is just negative x square root 1 minus x squared. Odd. Okay. So it was 83, 90. So that little symbol right here means this is going to be a future problem in calculus. I love these. Oh, God. Geeking. I'm geeking. Wait, I'm nerding. There's a difference between nerds and geeks. I'd rather be a nerd than geek. I've always heard nerds will inherit the earth. Geeks, not so much. In calculus, it's all about either finding rate of change, that's what we do. We like to find, remember that song? Rate of change, related rates, max and mins. And we also like to find area. We use little rectangles like this to find area. And then we make those rectangles infinitely small, so we have an infinite number of rectangles to add up. And then you have area between two curves. And then you get to take a little crank like this, and you spin it around the x-axis, so you get something down here that looks like this, and you get this solid with this donut hole in the middle. So it's like a nut. And it's coming out like that. And you got to calculate the volume of that piece that was spinning. Or we can turn it around the y-axis. And then you get this over here. And so you get this. And it's like one of them bun cakes. So it's the volume of the bun cake. And it's all about knowing how to calculate this. What's going on between here and here. That's all it is. we want to know what is the height of that rectangle as a function of x. So let me just use a couple of numbers. This highest point looks to be at a 3. This down here is a segment who has a height of 2. So if we took this rectangle that was right here, so the highest point is a 3, this is a 2, what would that height be? 1. How'd you get 1? Exactly, you subtract. Here's how you get that. The total distance from the very top point, that is a total of 3. This distance from the bottom of the rectangle, this distance was 2. So what you have in between is 3 minus a 2. That's what's left over. Okay? If it works there, guess what? It works everywhere. The top of the picture, all of these points are basically made by plugging in any x in between 1 to 3. So if I plug in 1.5, the height here at 1.5 is negative 1.5 squared plus 4 times 1.5 minus 1. That would be the y value. The bottom point would be 2, so it would be that high point minus whatever, minus 2. Plug in 1.5 and then minus the 2. Plug in, 1.9, plug it in, and then subtract 2 from it. They want the height as a function of x. So when you want the height, it's top minus bottom. So that height is the top of the function minus the bottom of the function. So the height here is going to be the top, negative x squared plus 4x minus 1. And then you're going to subtract the bottom piece, which is just 2. So the height as a function of x, so we say h of x. If I combine like terms, well, there's no other x squared, negative x squared, plus 4x, negative 1 and a negative 2 make a negative 3. So now I have an equation. So instead of having to plug in and do this number minus 2, this number minus 2, this number, I can just plug in, if I want to know, 1.8, plug 1.8 into this. If I want to know 2.6, plug 2.6 into this. I have one equation that satisfies all the heights for everything.
So would 94 just be 3? 3 minus 0?
So, well, that's 3 minus 0 is that one. The bottom of the function is this one.
Oh.
So this is always 3, the top, minus the bottom. Now look, 2 terms, parentheses, 4x minus x squared. Because if you don't put parentheses, you're not going to distribute the negative. So the height would be 3 minus positive 4x minus a negative x squared would be plus x squared. Now, exactly at 1, the answer is 0. Because right here, when you plug in 1, the y value is 3, and it looks like down below, when I plug in 1, I should also get a 3. 3 minus 3, top minus bottom, gives me a height of 0 at that one point. Plug in 1. 3 minus 4 times 1 plus 1 squared. 3 minus 4 plus 1, negative 1, but yep. Right there, the height is 0. And when I plug in 0, the height should be 3. 3 minus 4 times 0 plus 0 squared, yep, 4 minus 0, 3 minus 0, plus 0, yep. When I plug in 0, the height right there is 3. Top minus bottom. Okay. And then here's what you would do if you were actually going to find the exact area. We would integrate that, because that would add up all the rectangles from this x value, which is 0, to this x value, which is 1. And integrating is undoing derivatives, and that's something, again, calculus. But you know what? A lot of people do the integral. Oh, I take that back. It has to be an integral. I was going to say, that almost looks like a triangle. And if this was, instead of 4x minus x squared, if it was just like a straight line, it actually would be the area of the triangle. You could do it calculus, but just make a triangle. But because this is a curve, that we don't have an equation for that kind of a curve. So that's why you got to do it with integrals. Now, if you drew the triangle exactly right there, then the actual area in blue is a little bit less than the actual triangle. So now we're going to talk and walk 99 to 104. And I'll tell you right now, how long it's taken to do all of 1.4's examples is exactly the same time it took Monday or Tuesday, Thursday. So yeah, we are behind them, but we are at pace with them because of the days we've had on. So the directions. Matching. Basically, it's matching, so there's really no work to show. Match the graph of the function with the description, A, B, C, D, E, F, the description that best fits the situation. I know I mess around with these too much because I hate that negative space that you see. Oh, I know it. Written down magnification. So the air temperature at a beach on Sunday, the height of a football kicked in the field goal, the number of children in a family over time, population of California as a function of time, the depth of the tide at a beach over a 24-hour period, the number of cupcakes on a tray at a party. We've got a step function that's going up. This is just a segment that's going from left to right. It's got an endpoint, and then it has an endpoint. And it's getting bigger, it's increasing as you go from left to right. This has an endpoint and an endpoint. It goes up and it comes down. So like an upside down parabola. This has a beginning, it goes up, comes back down, goes back up, but it stops. So it's a set value time. This is a lot like 100, but it goes up and comes down just a little bit. And this is a step function, but it's getting smaller as you go from left to right. The y values are getting smaller. So the air temperature at a beach on a sunny day. So if you're at the beach, the temperature is kind of gonna go what? It's gonna go up, and then it will gradually come back down. Now, step function, right? Because the temperature can't go from 80 degrees and skip everything in between and go to 102. You can't have it. So the steps are up. Would it go up, come all the way below where it started and go back up? Nope. Go up, come back, no, because it basically is dead. So it started lower and then go up, maybe. Start here, go up a little bit, come back down, maybe this one. I'm 100, 103, I'm kind of on the edge. That's why you're doing this. How did a football kick in a field goal attempt? Do you see it?
Yes.
Which one? 101. Ball goes up, has to come down. The height increases, it reaches a maximum height, and then it's going to come back down. Okay? So 101 is B. So that's it. And then C, the number of children in a family over time. So let's hope none of the kids die. Start a little more. Children increase, but that means, let's say this is 3 kids and that's 5 kids. Are you going to have like 3.1, 3.2, 3.3 kids? No. I certainly hope nobody dies. Hopefully nobody dies. So I'm thinking step, because you would have maybe no kids, 1 kid, and then time goes on. Then you have 2 kids, time goes on. You have 3 kids, and then guess what? You stop because you don't have any more kids. So I'm looking at this. Here you start with like 10 kids. And they start losing one, you gotta call CPS. So 99 would be C. D, population of California as a function of time. So we're thinking of population of California as starting smaller and then, we're not talking about today, because everybody says people just leaving California. But I would say it's increasing. So increasing, no, we already got rid of that one, got rid of that one. So that's, I would think these two. And yeah. So I bet this is 100 is B, and that means 103 is A. Because you'd have a temperature at the beach, you reach a maximum temperature at the beach, and then it starts to cool down. Okay, the depth of the tide over 24 hours. So let's talk about that. You have high tide, low tide. Which one? And then tide is made by waves. Which one looks like a wave? Yeah, 102. High tide, so here's sea level, tide is higher than normal. And then low tide, tide goes out. And that means it's lower than normal. High tide, low tide, and that happens over and over again because of the moon's gravitational pull. Okay. And then cupcakes. Yeah, you're going to start with 10 cupcakes on a tray. Somebody takes one, you have 9. Somebody takes one, and over time, for like maybe 8 seconds, you have 9, and then after 8 seconds, it's down to 8. Okay, unless somebody grabs 2. I'm not the part of it. No. So 104 would be that. That's all you're doing there. The reason why I go over examples is because I've been in your shoes and I'm looking for homework on going. All he told us was greatest integer was less than or equal to the number I plugged in, and then I'm supposed to do this. That's why it's taken us long to go through this stuff that you might never have seen before. But we do, that's why I chopped up the homework, because I'm going to focus a little bit more on not so much more important things, but more focused things. I'm going to focus on more focused things. All right, well, I know the role. This is it, we're at number 4. That's it. So have a good weekend. Stay safe.